GraphQL. My name is Graham Albachten. Quick background on me. I was a resident of Featurey 1, the first and best of the full-time remote cohorts. And I was a fellow after that. My current work is with LexisNexis, where I am a full stack GraphQL developer. It's like it says on my fancy slide here. And I work at LexisNexis on their StateNet project. We work with multiple GraphQL APIs that are sort of being stitched together and used to query a whole bunch of information. I'm not at liberty to discuss a whole lot about what I do, unfortunately, but I will try to pull from what I know. And what I can say is you can imagine how complex queries get on this project when we talk about somebody basically searching for, I want to know all of the legislation that's being introduced in these states or jurisdictions with majority Democrats in these houses and a Republican governor, and they all have the keyword voting rights. Like those are the sorts of things, those are the sorts of like messy, complex queries and requests that we're trying to parse and serve to our clients. And so that's what I work on. It's a lot of fun. It's a really awesome team. It's a really awesome project. Hit me up if you want to talk about it. I could talk about it all day. But this talk is geared towards GraphQL, and it's geared towards newcomers to GraphQL specifically. The reason I chose to talk about this is that it's a technology that I found increasingly relevant to a lot of people who were hiring, and it's a technology that I really enjoy working with. I'm going to try not to spend too much time on syntax, although honestly, we have to spend some time on it to really have a common language and framework to discuss this stuff. But there are other speakers, writers, and YouTubers who have done that better than I can, or at least as well as I can. The goal of my talk is really to introduce you to a wide range of GraphQL approaches and implementations and tools, and to help you see what it is good for, what problems it tries to solve, and what use cases it has, and to think about your APIs in terms of graphs when you are building or improving an API. So that's the name of the talk. GraphQL was developed by Facebook, now Meta, in 2012 and open sourced in 2015, but it wasn't technically released out of its preview stage until 2016. So that is all to say roughly forever ago in engineering terms. For what it's worth, GraphQL is undeniably very popular. It is on the rise. These numbers have continued to go up. That being said, as impressive as these numbers are, they're not really a good metric for whether a tool is viable or useful. So given that we are holding ourselves to a higher standard and will not simply accept that a popular tool is a tool worth using and investing in, the goal of this talk for me will be first to explore the problems that GraphQL seeks to solve and the merits of GraphQL in solving them, as well as the limitations. And with that out of the way, we can sort of take a quick and dirty dive into GraphQL syntax and specification. And finally, armed with that knowledge, we can talk about some more specific advanced topics in GraphQL, full stack GraphQL, limitations, tooling, testing, other considerations like that. So here's that roadmap. We will focus primarily on using GraphQL with JavaScript and TypeScript, because that's what I do. Although I'm going to regularly remind us all that GraphQL is language agnostic. There are implementations that you can use in virtually any mainstream language that you can think of. If you want to use Python, go for Graphene. If you want to use React on the front end, maybe you want to be touch and relay. I'm going to try and remind you at various points that some of what I talk about might be specific to a certain framework or a certain client or server, but most of what we talk about will be pretty universal. And I'm also going to invite you at various points to open up your terminal if you'd like, your browser, your IDE. And depending on time, we might even try some live coding so you can all have a good laugh when I spell something wrong. And I'll periodically pause to check for questions in the chat. Feel free to use it if you want to get a question down before you forget. When I ask for it, use the raise hand feature and we'll just sort of take it as it comes. There is a lot to get through here, and let's start with what the heck is an API. So it stands for Application Programming Interface, which basically just means a software intermediary that allows two machines to talk to each other in a structured way. These two machines, a server and a client, typically talk to each other so that the client can ask the server for something, some resource or data. And often when we talk about APIs, we are talking about requesting information from a database. So we're talking about requesting information through some middleman. So a well-structured API will dictate what you can ask a server for, how it will return it to you, how you can further specify what information you want, and how it will handle problems that arise when that information doesn't exist or when there's a problem getting that information. It also means talking about how APIs will mutate or update some source of truth. Again, usually a database. As I said before, why we bother to use GraphQL is in fact very important. As developers, we don't always get to choose our tools, but wherever possible, we ought to be prepared to voice our opinions and consider our goals and trade-offs when discussing our tools. And as with any tool, GraphQL will only help you if it truly suits your use case. So your team, your goals, you have to have these discussions. To understand GraphQL, we have to understand its context and what problems it sought to solve. You can go ahead and ignore the first two options on this timeline here, but I think it's important to consider that REST has been the standard way to talk about APIs for a solid 20 years now. Now, just because it's 20 years old doesn't mean it's bad. It's very useful. It is a very good standard. But because REST has such a strong foundation and because it is so ubiquitous, a lot of times people look at GraphQL and APIs and say, wait, this isn't like what I'm used to. This isn't like REST, and then they get frustrated. So I want to do a comparison of REST and GraphQL so that we can understand where it's coming from. So we'll get started in earnest here. REST is representational state transfer. It is a standard that indicates that we think about RESTful APIs in much the same way that we think about local state or global state. If you work with Redux, you may have noticed that the reducer pattern actually shares quite a lot in common with querying a RESTful API. You give it some action, get, put, delete, etc., and sometimes an optional payload, so the request body, and it retrieves or updates some external source of truth. The main difference is that Redux and the broader Flux paradigm exists on the front end, while RESTful APIs interact with some external server. This is what we mean when we say that REST is a virtual state machine. GraphQL is a query language that describes data as well as a server-side runtime that is capable of parsing and responding to those requests in a very flexible way, you'll find, where REST will point your requests at the appropriate endpoints where resources exist, usually based on query parameters that exist in the URL that the query is pointing to. GraphQL is going to expose a single endpoint where all of our data is available. And it's going to parse through a query string to decide how to respond to those requests. GraphQL does not operate with endpoints, but rather sits on a data hierarchy. It is best to think of your GraphQL servers as a series of nodes and pointers or edges that describe relationships among data fields and leverages those relationships to make your API extremely flexible in what it can do to respond to those requests. So here's a simplified view of REST. We've all sort of seen this sort of thing before. And I think this has been pulled right from the GraphQL docs, by the way. This is a pretty good indication of what we're about to explore, which is some of the limitations. Here we have a GET request up on the first sort of bar there, line 1, that is asking for information about a user by some ID. So we find the user with that ID and we return it. But if we want more information about that user, we might have to go to a different endpoint with that ID and with that user in our possession now and make an additional round trip request, and so on and so forth. So let's see this in a real live example of a RESTful API that I've worked with on a personal project in the past. Now, don't judge, this is old code and it's not great, and that is not meant to prove that REST is bad or wrong just because my code is bad and wrong, but I think it shows a pretty nice idea of what sort of problems you can run into with a RESTful API. I'm a huge nerd. And when I'm writing code, not writing code for LexisNexis, my pet projects all involved tooling for Dungeons and Dragons. So we're going to look at the D&D 5th edition API, which you can load up in a new tab right now if you'd like. D&D 5e API.co. I'll actually even show you where that goes right now. dnd5eapi.co. If you want to get a jump start, you can even go to the GraphQL API, but we'll get there a little bit later. We're going to start with their RESTful API. Yeah, so this is the task that we're setting out to do here. This is what I was trying to do with this RESTful API, is I wanted to write a query that would fetch data from this API with a list of features on a given character class. Don't worry about the nerd speak. The data should include the feature's name, level at which the character could use it, and a description of that feature. That's all I set out to do. So I want 3 pieces of information for every feature that a given character class can actually use. So the first problem that we're going to see is getting more than we bargained for, getting overfetching, getting more from the RESTful API than we actually wanted. Because REST is built off of endpoints, we are at the mercy of those endpoints when it comes to what we can get back. If we want only a few fields from what that endpoint offers us, we are stuck receiving more data over our internet connection than we may want. And this is actually a huge problem for APIs at scale. Your customers, if they're using their phones, are probably paying per gigabyte when they access your applications. This costs them money, and it potentially slows your server's ability to respond. And this is in fact why Facebook created GraphQL, was to stop bottlenecks in their APIs specifically for users of their smartphone application. Deep breath, vulnerable moment for me here. This is actual code that I wrote like a year ago. Don't laugh, we've all used class components before. So this is pretty ugly, but it's not outside the realm of reason. If you're using hooks like you should, you'd probably do all of this in a use effect call. But you can start to see already how nasty this is and gnarly this is getting. First of all, there are 3 fetch requests on this screen. Notice that the first fetch request is querying the class's endpoint using an index string, which in this case is the name of the character class we want to query. And because all developers want to be great and powerful wizards, we're going to focus specifically on the wizard class. So we get the wizard class information from this first query at this endpoint. We parse it, and then we save it to state on line 20 and 19. What do you imagine we are getting back here? What do you imagine is the shape of the object we're getting in response? Well, it looks like this. It is a 200-line monster object with tons of information that I actually didn't need. This is absolutely unacceptable at scale, where our users are demanding speed and do not deserve to be overcharged for the data that they are paying when that data is not actually being effectively consumed. But it actually gets worse because this query here both overfetches and it also underfetches. It both gets more than I want and doesn't get me everything that I wanted, because the class information we got here includes information on wizard base features, but there's in fact an entirely separate endpoint for features that the wizard gets based on their character class's level. So now we need to make another fetch request, and that query beginning on line 16 will only give us back a features array, which we check on line 13. You might expect that features array to have the information about features that we are looking for, but for whatever reason, and I give these very generous developers nothing but respect for this, I'm sure they had their reasons, they only give us the feature's name and level. For the description, they give us another endpoint. So now we need to make another singular fetch request for everything in that array, each feature that we want. That is known as the N+1 problem. We have to make another round trip request for every single feature in that array. It's a huge problem. If you're a Codesmith resident or a former resident, you may remember working with the SWAPI, the Star Wars API, where getting information on films for a given character required a lot of time to come back because we had to make a new query for each film that that character had. It is a pretty big pain point. Now, I don't want to give the impression that the only benefits of using GraphQL is speed, because frankly, that isn't always the case, although I would argue that fewer round trips are a major benefit here. There are many benefits to the developer experience GraphQL offers, and for one, it can dramatically reduce the pain points that are associated with versioning and extending or extensibility. That point on line 12, where the base URL changed, actually broke my code when I was dusting this fetch request off for this talk. And that's because they updated the API. And since they updated their endpoints, my code was pointing to an endpoint that no longer offered the service I was asking for. The flexibility of GraphQL is designed to limit versioning pain points, and it also does it so well that many GraphQL APIs simply forego versioning altogether. And since GraphQL queries are based on arbitrarily nested requests and relationships between data, adding new data just means connecting it to a previously existing node. The front-end devs get to decide what data they want back, and they are free to take it or leave it. Just for fun here, let's also take a second to look at the docs for this API. These are the docs we get for the RESTful API for 5th edition D&D. We have the classes information, which is that monster object I showed you before. But to get information about the features, we actually have a different endpoint for that. We also have a different bucket of features information based on the levels that those classes get as the player character continues to level up. And all of those features that we get from both of those endpoints actually lack the description field that we were looking for. So we would need to make a full new request to a completely different endpoint. Wouldn't it be nice to be able to dictate in your request, these are the fields that I want, and this is what I expect to get back? And rather than organize information by endpoint, why not organize it by the relationship between the different types of data? Does it make sense to sift through all features to find the wizard features, or could the wizard class simply point to the features it gets as it levels? This is complicated by the fact that it might share features with other classes, but still you might already be able to see the sort of bare bones of a different way to create and think about APIs. There's another issue that we've already sort of touched on here, which is that the docs resemble this menu, but due to the limitations of balancing the number of endpoints you write and the amount of information being offered in return, it's kind of a limited menu. Here's what you're going to get, deal with it. No, you cannot substitute fries or a side salad. You'll eat what I made and be happy with it, darn you. And when the responses are large objects like this, it becomes a huge pain to deal with TypeScript or any other strongly typed language, because we might not really know what shape we're getting back until it's too late. I mean, would you like to type this interface if you're working with TypeScript? I'll leave it to your imagination. So this is what that same query looks like in GraphQL. And if you're like me, this is probably a really satisfying, peaceful piece of code to look at. It's soothing. This is what the query looks like to get the information we needed all that code and all that thinking to do before. What do you imagine will be the shape of our response here? Well, we're probably getting an array, since I see on line 2 features, plural. So we're probably getting potentially at least more than one. And we're probably going to filter that array based on the class index of wizard. So that's going to filter out from that array the things that we're not interested in. And it's probably going to give us for each of those features a name, a description, and a level. And that is exactly what we get, wrapped in an object with a data field. What you're looking at here is actually, I showed you a little bit of it before. This is the GraphQL Playground. And I'm actually just going to open it up now so you can see what this looks like from a front-end developer's perspective. I've got the same query sort of loaded up here. This, I didn't create this. I didn't have to do any work to get access to this. This exists by default with any GraphQL API, as long as you have not turned off introspection. There is no extra work to get at this. And if you go over here to the Docs tab, it'll actually tell you exactly what we're allowed to query on that features object and all of their types. Super, super useful stuff. Very sexy to my thinking. Very, very pleasant to work with. Now, the trade-off here is that there is a fair bit of work that goes into making an API this comfy and cozy to use, and that's part of the challenge of GraphQL, especially on the back end. And it is one of the considerations we have to make when we're deciding whether or not GraphQL is the tool that we truly want. But here are the benefits that you get. It's extremely easy to specify what we want on the front end. It's declarative. We got back exactly what we were looking for, no more and no less. And we got it back in the same shape that we requested it. That is magic. We didn't need to make multiple round trips. There were no endpoint dead ends. In fact, all of these fields and objects were queried at one endpoint that exposes everything the API has to offer. The documentation is built in. Again, this docs tab that you're seeing expanded here in the GIF is not written by anyone except for the creators of the GraphQL Playground. This comes out of the box through a feature called Introspection. You get that for free, no extra work required. Along the same line is extremely type safe. We have a really clear idea of what types we're going to get back. And while we can't really see it at work here, I can tell you from experience that adding extra fields to this query or additional fields to the API won't break anything. Since we're getting back what we asked for, if we want more, we have to say so. That makes it extremely extensible. So that's the end of my talk. GraphQL will make you rich, immortal, and popular. Thank you for coming. Just kidding. This is a good time to quickly pause for questions. I'm going to take a quick glance at the chat here. And now let's see here. Oh, will you increase your font size? Oh my goodness, I'm so sorry. Well, I'll do my best now, my friend. Any other hands in the chat, Caitlin?
I think we have one question from Jose Bourbon. What resources do you recommend in order to pick up GraphQL?
There are a few. For one, the official docs are actually really excellent. There's also, I'm going to show you a slide in a little bit that'll have a couple of resources. Yeah, we'll get to that in a second. It's like 2 slides away, actually. You anticipated precisely what I need.
Amazing. I have one other question that was just sent to me directly. Could you pinpoint, I'm sorry, let me just read this really quick.
Sure.
Okay, so this person's asking that they could never pinpoint a good definition for exactly what like GraphQL is. So in your very honest opinion, could you kind of sum it up in 2 or 3 sentences, I guess they're asking?
Sure. If I were to describe GraphQL, first of all, I'd say it's spec, which means that the implementations are going to vary. But ultimately, it is a query language for APIs. So if you think about SQL as a structured query language for databases, GraphQL is a structured query language for fetching information from a server. That is, I think, the heart and soul of it.
And I think we have one final question in the chat, which is Tori, when would you not want to use GraphQL?
I think at this point, there are 2 big factors that I would consider. One is the experience of your team. If you're working on a team where no one has worked with GraphQL before, I think you're kind of setting yourself up with heartbreak to jump right into it. That being said, there's nothing stopping you from using REST and GraphQL. You can start to build it piecewise. So that's a consideration. The other consideration I'd give is just how complex and how much relationships do you see in your data? If the data is not super relational and you can truly say these pieces of information that we're going to have our API sending back and forth are all very disparate and not connected, they don't have a hierarchy, then this is probably not necessary or useful to use GraphQL. It's probably more trouble than it's worth at that point.
And I believe one other question is, what's a good first project to wrap one's mind around full stack GraphQL?
We're going to do it. We're going to do it. I would say the first thing that you should do is try to write a GraphQL API, is write some resolvers and some schema. And that's what I'm hoping to get to pretty soon. If we don't get to it, I'll give you a couple of good resources for where you can go and see that. All right, let's move on. We've got a lot to get through here, but presumably I've done a fantastic job. I have convinced you, Graham, you're amazing. I want to learn GraphQL. I want to build flexible data-driven APIs that scale really well. What are the guts of the thing? So we're going to move fast. It's not the purpose of this talk to go through the syntax of GraphQL. So there will be gaps, but we are going to touch on the fundamentals so that we don't have to feel lost while looking at GraphQL code, and so that we can talk on some of the more interesting, challenging topics. So think of this as sort of, you know, at Disneyland, the ride where you sort of just slowly loop around the entire theme park and you get excited about what you're about to do. That's kind of what this talk is supposed to be. So as far as resources go, we were just asked, there are plenty of great resources online. GraphQL.org/learn is the literal GraphQL docs. They are fantastic. How to GraphQL is also a really great one. And if you are interested in working specifically with the Apollo suite, then Apollo GraphQL has a learning platform called Odyssey, which is fantastic. I'm not here to sell anybody on Apollo, but it is what we use at LexisNexis on both the front end and back end. And it is definitely what I would recommend if you want to get started with GraphQL, because I think it is, especially if you're working in JavaScript already, I just think it's such a rich ecosystem and it has such a great team of dedicated open source developers working on it. And it has fewer rough edges, less steep learning curve than something like Relay, which is a really cool tool, but maybe I started with Relay and frankly, I wish I hadn't. I think it gave me a very, it scared me off of GraphQL initially, whereas Apollo is a very sort of inviting feeling. If you are more of a hard book kind of person, learning GraphQL from O'Reilly is delightful. It's short. It's only like 100 pages, and you can even skip the first couple of chapters and get right into the syntax. And then he walks you through a pretty wide-ranging example using Apollo. So it's a great way to start tinkering. So let's move on to the actual meat of the thing here. What the heck is GraphQL? Well, fundamentally, it is spec. GraphQL is language agnostic, which means that GraphQL itself is a specification. It's not a hard machine. There's no GraphQL machine anywhere. It is language and transport agnostic, which means that implementations will vary. But apart from that, it is a query language for GraphQL, for APIs, which is what the QL stands for, Graph Query Language. It is a runtime for servers, which parses and handles those requests written in that language. But overall, do not forget that some of what I share with you today will be specific to that implementation. GraphQL, the query language, and GraphQL, the runtime, are both, however, universal at the very least. So what is a graph? If GraphQL is a query language for graphs, what is it? Well, it looks a lot like a tree, honestly. If you can imagine grabbing that top node in the middle there and just sort of picking it up and letting all of the other nodes sort of hang off of it, you get something that looks a lot like a tree structure. Not a binary search tree for sure, but a tree nonetheless. These structures have a lot in common, but the main difference is traversal and where you start. For GraphQL, we're going to talk about jumping into the graph. You have many options depending on your API for which node you can start at. And from there, you can move to any node that has an edge connecting it. The nodes will be our data or object types, while the edges, those lines, will represent connections or relationships that offer possible paths for traversal. So this might give you a little bit more of a familiar sense of how we envision our data in terms of graphs. You can see how if we start, as we were earlier, at the classes object, and we select a specific index and traverse that to one specific index option wizard, and then move to all of the connected feature objects, each of which will have this level, name, and description information that we were looking for. This is the kind of traversal that our APIs will seek to emulate when we create a GraphQL server. Oopsies. There's another example that I want to showcase really specifically. I know it's a little bit bright. I apologize for that. But these guys here say user, and these guys here say post. I did a bad job of balancing this for our screens. So you can imagine a social media application like, say, Facebook. Each user can have a number of different posts, but each post is going to have one canonical author. So now we can sort of see how these nodes, their relationships have meaning too. The link between a user and a post might be authorship, but if this person is a friend of yours and they have liked your post, then the relationship between that user and that post might be liking. The relationship between users could represent friendship. you'll see as you continue working with GraphQL, if you continue exploring it, that the more time you spend with it, the more you start thinking in these terms of entities or nodes and capabilities or capacities, which are the edges. That is what GraphQL, I think it's a major feature of the language, that it sort of forces you to consider your API in terms of entities and capabilities. What can I do with these things? So syntax. Here's our query again. I use the query keyword at the very first line to identify that this is a request for information. You can think of it like a GET request, although you can actually omit this. GraphQL queries assume that a query is the default sort of option. We give it a name, feature by class, just to be nice to ourselves. Somewhere in our graph, we know that there is a features object based on this query. And since we can query this features object directly, we know that at the root field of our query, at the root of our API, features is one of our jumping off points, one of the places that we can jump into the graph and start traversing our data for information. It is worth mentioning here really quickly that there's nothing fundamental about the filter keyword here. It's not a keyword in GraphQL. It's just specific to this particular schema, but it is a common approach, and we'll talk about that a little bit. If you'd like to try making this query yourself, you can open up your terminal right now. Assuming you have access to the curl binary, you can CURL, type in the endpoint, which is HTTPS www blah blah blah. The -8-H sets a header for an application JSON content type, and the --data will tell us what the query is that we're sending. Don't be turned off by all the \n's there. Those are just new lines, but effectively this is what you're doing when you make a GraphQL query. You are receiving information by sending off a request over an HTTP connection. So that's what a GraphQL query looks like. On the front end, you'll typically be using a GraphQL client to handle sending off the request. But as you saw with curl, you can just as easily use any other standard HTTP request to get it done. When you're using a client, many of them like Apollo or Relay will provide a custom hook that you can pass your tagged query string into in React, for example, when you invoked it, along with a variables object if you are using variables. And they'll give you back your data, as well as a loading and error Boolean. And it'll come in this shape, the same shape that you requested. The next piece of syntax that we should briefly touch on is syntax fragments. So you'll notice that it's very similar if you're working in JavaScript to spread syntax or REST parameters, this ... features on line 3, or ... features fragment on line 3. All we are doing here is drying up our code. It is taking those 3 fields, name, description, and level, and spreading them out on our all features query up at the top. This allows us to reuse those fields because we might need that fragment on a wide range of queries. There's another reason that you might use fragments, which we'll see a little bit later, but just put a pin in that for now. So fragments, terribly useful. Variables, in the previous examples, I've been hard coding my parameters through these parentheses. This syntax here that you're seeing is a little bit of an example of passing in variables so that we can keep things dynamic. Here they've named an input type, filter many features input. That's a bit of a mouthful, but it's pretty common to name your input types and your types generally this way because it's very descriptive. It tells us that this is input type is a filter, which means it's going to refine our search. It tells us that we're going to be receiving potentially more than one object in response, so we can expect an array. And that tells us that this input is for a feature type. We pass arguments to the query with parentheses, like we do on line 2. And then we identify the variables that are getting injected into that query with a $, the bits that we want to change potentially later on. On line 1, right at the top here, we are naming that variable and defining its type. We don't necessarily need to name the variable after the $, the same as the type, but it's a pretty common pattern. just for ease of use, just because it's pretty straightforward to identify what that variable is supposed to be. And then on the actual object we're getting back, we pass down that input object into the filter argument, which is one of the options on features. Don't worry if some of this is going a little over your head right now. I know I'm going like a mile a minute here, but the pieces sort of are interconnected and they'll start to sort of fit together as we keep going here. So this right here is the GraphQL schema, or at least a tiny, tiny slice of it. These are our type definitions in the same way that you would write type definitions in TypeScript. At our top level, we have the query type, which is considered a root type. More on that later. Beneath it, we are going to define every single type that will allow us to jump into the graph. You can think of these headings under query as our entry points, where we begin to traverse our graph, and they define where we can start exploring the interconnected data of our graph. Note that the schema defines what we can do, but it does not actually implement the API. The schema is therefore a document or a contract between our front end and back end. It describes what we can and cannot do in much the same way that, say, for example, a mongoose schema defines what we can and cannot do with the database. I also want to note that the schema definition language is different from the GraphQL query language, which is what we were writing when we made a request. The schema definition language shares a lot in common with GraphQL, the query language itself, but it is mainly built to define types. You can download the schema if you want. You can check out the npm package get GraphQL schema, pass that command, the URL for our GraphQL endpoint, and then redirect the output into a schema.graphql file. It's a common pattern. So you're hearing me talk about types a whole lot. And really that's sort of the first big hurdle we have to get over, which is to understand GraphQL and the schema definition language. We have to understand the type system that it is based on. Good news is that it is quite a lot like what the types that are available to us in JSON, because that's really what it was designed to do, is to work with JSON. So there are root types, custom object types, and there are scalar types. That makes up the foundation of the type system. We've already seen one of these root types. These are the entryways that we can interact with our API. By far the most common one is a query, which is you can think of as a GET request. You define the query in your schema as an object where each field is one of those entry points we discussed earlier. The query type dictates what objects we can begin exploring on in our graph. Queries exclusively return data. It's not modifying, it's not deleting, it's just returning. The next most useful root type is called mutation. This is sort of the multi-purpose type, Swiss Army knife. It is an object that has as its fields all the different labels for what your user is allowed to do to change your graph's data. This could mean creating new data for a database, as with, for example, a post request in REST, modifying that data, or you could delete everything, as on line 10 here. Burn it all down if you want. I wouldn't recommend it, but I'm not judging. I also want to note here, this example is not actually GraphQL. This is not schema definition language either. It's just JavaScript. This is a resolver, which is how we are actually going to be implementing the schemas that we are writing. So you're noticing probably at this point that there are a few moving pieces on the back end side of these things. The front end experience is very pleasant. The back end experience requires a little bit more work, defining our types, writing our resolvers. We'll get to that in a bit. The last root type is subscription, and we're not going to touch on it too much because I consider it a bit more of a niche advanced situation. Bear in mind that the tool that this was originally designed for was, it was originally designed for Facebook and for Facebook's needs. If you define subscriptions in your schema, what it's going to do is it's going to open up a WebSocket when your subscription runs. And rather than immediately sending back that information, the subscription remains open in a publisher-subscriber relationship and will send you information when those fields you've subscribed to have changed. Think about likes on a Facebook page. You can see them update in real time without reloading your page. That is a subscription under the hood. It is listening for changes to how many people have liked your status. So after the root types, we have object types, and this is kind of the bread and butter of developing a schema. These are representations of your data and define their shape and relationships. So those nodes and edges all happen right here. Within each type that you define, you have these fields that can reference a scalar or another object type. Eventually, all of these fields must at some point down the line reduce to a scalar type, which is cold, hard data. We're going to write some of this stuff later, but for now, let's just talk through what we see here. So I've made a wizard type using the type keyword on line 6. It has a name field, which is a string, an ID field, which is an ID, a spells field, which is an array of spells. Well, what's a spell? Well, I have to tell GraphQL what that is, which is why I define it above on line 12 and say a spell is going to be an object that has a name, a school, and a level. What's a school? We define that up above as well. This is how GraphQL goes through your schema, goes through the definitions that you write. It says, what is this? You have to tell me. And if it's not some hard-coded data like an integer or a string, I need you to define it for me. That's the work with GraphQL. A scalar, that last sort of group of types, is type bedrock. It is the cold hard data that your client is requesting. We have integer and float, which boil down to JSON numbers, string, which unsurprisingly is a JSON string, Booleans, true or false, and ID. ID is a weird one. It will be transported as a JSON string, but GraphQL does do some work under the hood to validate it and check that your IDs are serialized and unique for a given type, which does save you quite a lot of heartbreak. All of these could come in lists or JavaScript arrays if a given field allows for it. All of these fields are either nullable, meaning they can return nothing or null, or non-nullable, in which case GraphQL will throw an error to the front end if they don't have anything to send back for that field. And all of those three options, all three of those options, list, nullable, non-nullable, also apply to objects as well. So we can send back a list or an array of objects if we want, which is what we saw earlier with our query for features. I'm going to pause here actually for general questions on the sort of type system. Any burning questions there?
I believe Ed has asked, is there a binary data type?
There is not. However, you're going to see in a minute that we can actually create custom scalars. We can create our own ways of validating our data.
Awesome. And Michael asks, are GraphQL floats regular floats or doubles?
I actually don't know the answer to that. That's a really great question. I would check the GraphQL spec for that. It also makes me wonder what JSON floats are, or what JSON would allow. So I'm willing to bet it depends on your transport.
And then next song from Johnson is, are subscriptions necessarily implemented with WebSockets, or is that just the most common method?
That is also a great question. My knowledge of subscriptions is a little bit on the shaky side because it's such a niche topic. I've always heard them talked about in terms of WebSockets, but again, I would check out the GraphQL spec to see if they have any other ways of doing that. I imagine there are other ways to transport that. Okay, let's keep moving. So, as we were just saying, custom scalar types are a thing. So if you looked at these data types and said, that's not enough for my needs, you can write your own. This example comes courtesy of Apollo GraphQL. We create a date scalar. In order to create a scalar, we have to give it a name, but we also have to tell our backend how to parse and serialize that information. So that serialize function on line 15 is telling us, how are we going to convert our outgoing date object into something that we can actually transport over JSON? The parse value will say, how are we going to convert the incoming information that we're getting into a date object that we can use on the back end? And then that last one on line 9, parse literal, this is going to interact with the abstract syntax tree, the AST. that sounds really scary, but this is just a fancy way of saying how your runtime is going to parse through the literal string characters that you are writing into code that it can play with. So JavaScript, for example, has an abstract syntax tree. When you run it, that will look for white space, look for keywords like const, let, function, what have you, and decide, oh, that's where the function begins, or oh, this is where a variable begins. That's all it's doing here. There are many custom scalars. Like anything else in the open source community, many good libraries exist to import custom scalars, and the most recent updates to GraphQL spec, which just so happened to have been released on my birthday this year, October 26th, thank you very much, includes directives for inlining URLs that point to a custom scalar implementation. So you might not even need to download anything. You probably noticed earlier that I used the keyword enum for one of my definitions. Not all languages natively support enums, but GraphQL takes care of this for you under the hood. So even in something like JavaScript, you can use enumerables, which is just a fancy way of saying this type is going to have one of these 8 values and nothing else. It's going to either be conjuration, necromancy, evocation, whatever that nerd stuff is. So just know that whatever language you're working with, this is something that is available to you, and it can be super, super useful. Going a little bit deeper, oops, excuse me, going a little bit deeper with the type system, you can talk about polymorphism. So this is how we avoid repeating ourselves with our type definitions, but it's also how we can sort of refine our type definitions to describe more specific versions of the same thing. If you work with TypeScript, you're probably already familiar with interfaces. This is also very big in classical inheritance. Here we're saying, okay, we have a character, a player character, and that will have a certain number of fields. But then we have a specific version of that character, fighter, which implements all those same fields and will have a name, an ID, an inventory, features, speed, etc. But it's also going to have this left-hand field, right-hand field, and armor field. We can have a type wizard that is also a character, so it will still have name, ID, inventory, features, speed, but it will also have specific wizard features, spells known, specialization, whether or not that wizard has a magic wand. Another way to add flexibility to our schema is union types, where we can define a type that could be one of many other things. So if we're creating an enemy class in our schema, we could say that that enemy could be a fighter, it could be a wizard, or it could be some third type, a monster. Inlining fragments, I promised this earlier, inlining fragments helps us write our queries with polymorphism in mind so that we can query for similar fields or types that implement the same interface while also getting back fields that are unique to the more specific refinements or implementations of those interfaces. So here, and I'm going to call myself out here. I made a mistake. I missed the character field here, but here we're saying I want a character. And so I'm going to get the name, features, and inventory fields on that character. But with that ... on fighter, I am saying if the character happens to be a fighter, give me armor. And with ... wizard, I'm saying if and only if that character is a wizard, give me spells known. So you can see this is a very flexible and concise language that we have to describe what we can do and what we want from our API. This is a new feature. I'm not going to talk too much about it, but the recent improvements to the GraphQL spec, again, released on my birthday, actually gave you this option called intermediate interfaces, which makes so many things so much easier. It allows a type to implement more than one interface at a time. So you can get really, really fine-grained about how you want to relate different types. All of this talk about types, you're probably going, Graham, what happens to our APIs? Creating these types is ultimately, the goal is to create a schema, which again is our contract between the front end and the back end. You can do this in a single string in there with your server file, which we'll check out in a second, or you can do it in its own dedicated file. But all this is you're writing type definitions to describe what is allowed in your GraphQL API. The other half of work in creating an API, once you have your schema, is writing resolvers. So the code that whatever language you choose is going to tell your server how to deal with these requests, how to respond to requests on a specific object or a specific field, and what to give them back. So this one uses an imaginary database. We use that information to get a wizard from some ID, and then we return it. This is kind of the hard work of building an API. And if it seems like I'm glossing over resolvers, I am, because we're running short of time, but also because we're going to try and do a little bit of it in a second. Before we do that, I just want to touch on the introspection system here. This GraphQL Playground that I showed you earlier, I said it didn't require any extra work at all to create. This is just something that comes out of the box with GraphQL. That is because the GraphQL system allows you to request information about the schema itself. And with that information, you can actually ask GraphQL to tell you about what is allowed. You can ask it to tell you what types are available to me. Where can I move from there in the graph? How am I allowed to work with this API? This just happens out of the box. It's kind of magical in this way. We will touch briefly later on about shutting off introspection in production code, because you don't necessarily want malicious users to have access to all of the information on how to work with your database, but that's a bit of an advanced topic. So I'm just gonna throw together a quick API here. And warning right off the bat, I'll probably misspell something and that'll ruin everything. Be nice to me. But this is just going to be a really quick and dirty API, just so you can see what some of the things we're talking about looks like in practice. I'm going to use Apollo because, frankly, I like it. So we require that in. And that's going to be our server. That is the same as requiring an Express or any other service that you're using. I'm also going to require, this is kind of not super necessary, but just because I prefer getting some syntax highlighting here so you can see the types, you can see the syntax, I'm going to require in something called GraphQL tag. And I've already installed these. I've practiced this because I'm neurotic like that. But that's all we really need right now. We're going to define, let's define some wizards. Let's just say that wizard is going to be an object, and we'll say our first wizard will be named Gandalf. He's going to be level 20, because obviously. And his spells list is going to include Fireball and I don't know, shields. This seems like the kind of wizard that would use shield. I think that stands. And then we're going to make another wizard just because we can. Let's call it, I don't know, Graham. Probably level 1. And his spells list is going to say, we're just going to say shield. He's a new wizard. He's working on it. Obviously, we wouldn't store our data in local memory like this, but this serves the purpose for right now. So let's write a GraphQL server that can actually respond to requests about our wizards. We're going to need two things. We're going to need a schema or type defs in this case. And I'm only using the GQL tag in front of this backtick string here because I want that syntax highlighting. You don't need it. You could just write a regular string. And then I'm going to need resolvers, which is just going to be a plain old object. Using the glory of Apollo server, we're going to create a server. And we're going to pass into it our type defs and our resolvers. And it's going to complain at us right now because we haven't actually written anything. So let's actually write something. Let's write a type for our wizards. We know that our wizards are going to have a name, which is a string. It's going to have a level, which is an integer. And we know it's going to have spells, which is going to be an array of strings. We're just going to call it a string for now. We could refine these types and actually define what a spell is. We could make an enum for it, but for the sake of time, I'm just going to go quickly here. We need to define our query type so there's actually a way for our users to interact with our API. And let's call this query that we're going to allow our users to use all wizards. And what's this going to return? It's going to return an array of wizards. Here's our types. Simple, quick, easy. You'll notice that everything resolves down to scalars unless I've forgotten something. So now we need to actually do the logic that will serve this information. So we have a query type, which is itself an object. And we have one query that we need to write a resolver for called all wizards. Here's what that query is going to do. Oh, that was tough. Okay. So our query all wizards is just going to return our wizards here. Let's start up this server. And then we'll have it tell us that it's listening, like a good server should. And let's start it up. Now, is this a super trivial server? Yes, it absolutely is. But I hope you can see how some of these pieces are fitting together. We have our type definitions, which tells us what is allowed. We have our resolvers, which actually implements that API. And now, yeah, where did I say wizard instead of wizards? Ah, yes. Okay, I said wizards singular here, and I actually said wizard plural. Okay. So now our actual API is running. Let's take a look at it. Apollo comes out of the box with its own query explorer, similar to the GraphQL Playground, like we saw before. It's going to load up for us. It will give us a lovely GUI if it ever decides to load. There we go. It tells us a whole bunch of information about the GraphQL API that we are attached to. I think it's a little bit confused because I forgot to write an ID property here, but there it is. There's Gandalf, there's Graham. I can see that it's returning exactly the data that we told it to. Think for yourself about how you would connect this to a database, how you would connect this information to how you would expand it to add a whole bunch more information, how you could create an interdependency between wizard type and the spells type, for example. Maybe you want more information there. We're getting really close to time here, and I don't want to take up too much of anybody's time here. There's a lot more to discuss, but you can see that there's a lot. I hope you're starting to get a sense of how powerful this tool is and how flexible it is. I think this is probably a good time for me to pause for questions. And if we don't get to part 3, then I guess I'll just have to come back and do another one. What do we see here?
I am seeing a question from Dimitri. Hard to imagine how to query in React, trying to compare it to the RESTful API request. Do you send a request to the one endpoint in useEffect or some async function?
Yeah, so if you're using a GraphQL client, then usually you'll have some sort of, especially in React, there's like usually a custom hook that gets implemented that you import in, usually called something like useQuery, and it will be passed in the actual query string along with a variables object, if there are any variables you need, and it will return to you asynchronously the data that you need, along with variables for a loading state and for error state, which can be super, super straightforward to use in React.
Awesome. We have a few hands. I'll send it over to Becca first.
Awesome.
Hey, Graham. I was just curious about what the bangs after the type declarations were.
Yes, thank you. So the bangs indicate nullability. If you see that bang there, that is the GraphQL schema definition language of saying, way of saying this field, you're not allowed to return null here. You have to return information, otherwise throw an error.
Okay, that totally makes sense. Thank you.
No problem.
Over to you, Sean.
Oh, thank you, Kevin. Hi, yes, hi, Graham. Thank you for the high-level overview of GraphQL. I had a question about more of a project directory structure. How would that fit into, or better question, how would your file structure look like when it comes to utilizing GraphQL in your project directory?
Yeah, I've seen it done a couple of ways, and it really depends on the size of the project in my imagination. So for example, at LexisNexis, I'm sure you can imagine our queries tend to get very large and complex. And so every query gets its own file, and we have to save our queries into their own folder, and that keeps things nice and tidy. For a smaller API like this, I might just write the type definitions right in the server file like that. So it really depends on the scale of the thing. I will say the bigger that the project gets, the more granular I find it's necessary to be about dividing up your type definitions. And there are pretty easy ways to stitch them back together in your final server file.
Gotcha. Thanks so much.
No problem.
Over to you, Sai.
Okay, thank you. My question is how we translate our GraphQL, our query language, into our database query. And the second question is, if we have a greenfield project, which one we need to use? Is a RESTful API or GraphQL, or maybe using a SOAP API? Thank you.
You mentioned using, I'm sorry, can you repeat that question for me? I think I missed a couple things.
Which one? The first one or second one?
First part, please.
The first part. So the first part is, in the client, we create a query language, right? And how we translate that query language into the query in our database. So maybe we use SQL or Postgre or maybe MongoDB.
Sure. Yeah, it's very agnostic about that. So you can use any query language to your actual database that you'd like. I myself work a lot with SQL because the tables that we have access to tend to be very convenient for SQL. You can also do it with Mongo or any sort of any kind of database you want, really. It's just the logic belongs in the resolvers to decide how you're going to translate the GraphQL query into actually returning data to the front end. You can think of it as an integration layer between your database and your client. Does that answer your question?
So we need to create our own parsing language, something like that.
Yeah, I mean, you don't necessarily need to create a language, but you will not be able to get around writing the logic that will resolve these fields. That belongs to the server-side logic, to the resolvers.
Okay, I got it.
Awesome.
Over to you, Ron.
Thanks. As you were going through that last little code demo, I wasn't sure if you were like weaving in and out of the graph definition language and JavaScript, or are they intended to look alike, or is the graph definition language a preprocessor for JavaScript, for example?
Oh no, yeah, no, very good question. Thank you. The graph definition language lives totally separate from the JavaScript that I'm writing. The resolvers, like I'm writing right here, this is all just JavaScript. This is all just JavaScript. The only part that's actually GraphQL schema definition language is right in here. You'll notice actually, if I take away this tag, I told you I was using it just because I wanted the syntax highlighting. This is just a string. This is just a string which will be parsed by the abstract syntax tree into the GraphQL schema definition language. Does that help? Yeah,
and I was going to ask you about the bangs, but I think somebody else nailed it. And that's just a convention, or is it actually an operator in the definition language?
It is an operator. Yeah. That is an operator in the definition language.
Okay, great. Thanks.
No problem.
Great presentation too. In case I missed you before you go.
Thank you.
Back to questions in the chat. We have Michael who asked, do resolvers sometimes get particular about needing to follow a specific pattern for their function signatures, as in needing very precise parameters specified in a certain order? I saw that the first resolver you had as an example had parameters listed that were never used, but then all wizards had 0 parameters.
Yeah, so yes and no. I'm going to show you a couple of things here really quick, just jumping ahead to something I had for our sort of deep dive here. Resolvers do get a little bit hairy at some point, and part of that is because we may have information that has to live alongside our resolvers. So usually with resolvers, there's the variable information that gets injected into the query. That's usually passed in as the second argument, and we usually call it args. But there's also the first argument is called parent sometimes, or root, which is whatever query field came before it or up the chain. And this is how things can get a little bit hairy as you get into more and more deeply nested graphs, is that parent object describes what field this query came off of. So in the case of our wizards example, if we went from the wizards object to the spells object, we need to have some way of keeping track of what came before spells. Well, in that case, it would be wizard, because these spells are belonging to the wizard. Args, meanwhile, have the variable information that we need. And then sometimes we'll use this thing called context that you're seeing here, which is what we use often for authentication or authorization purposes. So you might have some session storage saved on that object to see if somebody's validated to use your graph. So yes, the convention you'll tend to see is either passing in parent args context or root args context. And it can get more complicated than that. It can get as complicated as your imagination wants it to be, but those tend to be the standards. Does that answer your question?
Hopefully.
I'm going to take that as yes.
Moving down through the chat, Ron asked a question, and Ron may have said this when you had your hand up, but just in case, for us newbies, what are the exclamation mark chars in the type def for? If that makes sense, it might be, yeah.
Yeah. So those exclamation points in the type definitions indicate that a field is non-nullable. So that helps us tell the GraphQL server, if you don't have information to give back for this specific field, that's not, it's not okay to send null. That has to be considered an error. I completely messed up my little window here. There we go.
Awesome. Moving on to the next question from Ed. Any comments in doing this in Swift?
Well, I have not worked in Swift. I wish I had, but no, I have not actually experienced it. I guarantee you, if you go onto the GraphQL docs website, they will give you a list of libraries or frameworks that work with Swift for GraphQL specifically. There are a lot of individual implementations out there.
Awesome. And then I think their last question, but I'll double check. If from Tori, if using TypeScript, do we get the benefit of not having to write type defs? I think I missed that part.
Oh, I wish I could say yes. Unfortunately, no. Although I will say that the nice thing about it is if you're using GraphQL and you have these shapes sort of coming back to you already, you're probably going to reuse those type definitions anyway. You're probably going to be reusing those interfaces. So the benefit to me is because GraphQL forces you to think a little bit more in terms of types, it's a lot easier to write those type definitions. I know, too bad, right? It's a lot easier to write those type definitions because you've already written them, kind of. And it's a lot easier to sort of anticipate what shape you're getting back. We use TypeScript across the board. We'd use a little bit of Go as well, but we use TypeScript pretty much across the board at GraphQL at LexisNexis, and it's super convenient. It works very well with GraphQL.
Awesome. To jump back to the hands up, Johnson, if you want to take it away with your question.
Oh yeah, thank you for the talk, Graham. I'm getting a lot out of this. My question was, you mentioned earlier social networks like multi-relational, multi-type entity graphs, like social networks were moving it. That GraphQL was made for those. I get the impression that it would help API consumers GraphQL will help API consumers with dealing with those kinds of networks, but does it also help developers in writing resolvers and kind of dealing better with that data model than with relational database or REST API paradigm?
You know, if I were to be perfectly honest with you, I would say I think a lot of backend developers view GraphQL with a little bit of suspicion because it is quite a lot of work to upfront consider the way that your data is structured and the way that those relationships exist or could exist in the future. I actually personally think that it's a bit of a benefit to GraphQL that it forces those conversations because it forces you to pause and think about what your graph is being used for. I will also say there's a lot to the architecture of GraphQL at scale that allows for dividing up and then stitching together your graph. So you don't necessarily need one huge domain graph for your entire business model. You could have several working together, and they could be a middleman between a GraphQL API or a legacy API or a REST API. They work pretty well together. The hard part is writing those resolvers, especially keeping in mind efficiency, because you're not off the hook for writing those resolvers in a way that resolve quickly and efficiently. But there are tools for that. You know, there's data loaders, which are super useful for GraphQL servers. You have to consider, you know, none of this is going to let you off the hook for writing good servers. It just makes the syntax for the front end team so flexible and so straightforward and declarative. I think that's the main benefit here. Does that answer your question?
Thank you.
Awesome, yeah.
Awesome. Okay, and then the final question, or we have two final questions, one in the chat, and then we'll go over to Becca. But Sai asked, can we use GraphQL to implement microservices?
Yeah, all the time, all over the place. I think it's, again, it's a matter of you can divide these GraphQL APIs up and stitch them back together. So you can have a graph for example, in our D&D campaign thing here, we could have a characters graph, but then we can also have a monsters graph. And those two can work together in our final product.
Awesome. And Becca, I'll let you take it away with the last question of the night.
Thanks. You might have already answered this. I was a few minutes late. I'm sorry, but I'm always hearing Apollo GraphQL. And what is the relationship between the two? Like, I know GraphQL is the language, but what is Apollo?
Yeah, so the GraphQL is more than a language. It's also a runtime, and ultimately it's just spec. There is a sample implementation made by Facebook when they open sourced it, but anyone can write their own client or server implementation for GraphQL that will parse that information or help you deal with making the queries on the front end. So Apollo client is the front end version of writing queries and sending them off to an API, whereas Apollo server creates the server for you that will allow you to parse those incoming requests and respond to them. There's also Relay, which is a really awesome tool. I don't recommend it if this is your first time with GraphQL. It is very opinionated and has a steep learning curve and kind of user unfriendly, but it is a fascinating tool. And there are many, many other implementations. But ultimately, they're all doing the same thing, which is treating our APIs as a graph so that we have a little bit more flexibility on the front end in interacting and diving through that API.
Okay, very cool. Thank you.
No problem.
Awesome.
Well, folks, so sorry we didn't get time for part 3 here, but it was really fun talking with y'all.
We'll just have to have you back, Graham.